Hello everyone. I hope you all are preparing well for the AP Calculus AB exam. In this series, we're gonna do all the questions that are available in Khan Academy step by step. I'll try to keep the videos short, like 15 to 20 minutes lessons per video. So without wasting any time, let's start the video. Um, so what you can do is just go to Khan Academy, sign into it, or you can even do the questions without signing into it and search AP Calculus. So there are, I hope you know, there are two levels, AB and BC. So first we're gonna do the series on AP Calculus AB, and after that we'll do the AP Calculus BC. As you can see, these are all the exercises that are available in the Khan Academy, and I was recording the video that couldn't be get recorded properly. I did the first exercise as you can see here, and but I'll do it again in this video, and after that I have not done any of these exercises, so we'll do it together. What you can do is, what I suggest is, you do the exercises first on your own, and after that you can again look at this video and get the solutions of all the answers, right? So let us start all the questions one by one. So the first exercise is based on limits intro. So this question is based on finding the limit from the table. As you can see, it is asking us to find limit x goes to minus 6 h of x. So if we have minus 6 like this, so if I'm coming from right hand side, we have to find RHL and LHL. Let's say I'm coming from this side, so which is this side, minus 5.9, minus 5.999, and then minus 5.999. As you can see, the value of h of x is approaching minus 1.02, so it is approaching minus 1. So my RHL is minus 1. We don't see this value, we see that what value it is approaching. And then from left hand side, you can see that from left hand side on the number line, it will be minus 6.1 will be here, minus 6.01 will be here, and then minus 6.001 will be here. As you can see that this one is also approaching minus 1. So when LHL and RHL both are having the same values, then this limit, this is called the complete limit, then it is said to exist. Here LHL and RHL both are equal to minus 1, so the complete limit exists, and it is equal to minus 1. So let's tick that option and move ahead. Alright, in this question the function h is defined below. So in this one we have to find a limit from the graph. The last one was from the table, and we have to give a reasonable estimate for limit x goes to 0. As you can see, at h, when h goes to 0, the graph, let me see if I can zoom it, the graph is approaching towards 2 from both sides. As you can see, it is approaching 2 from both sides. So now let's look at the options. Here it is 2. Now how to see the LHL and RHL? So stay close to the number, as close as possible. Like if it is x is approaching 0, so for LHL it will be like x approaches x is like 0. In the right hand side it will be like minus 0.001, minus 0.01, like that. So we have to stay close to the number, as close as possible, right? And from RHS, from right hand side also, the RHL, which is right hand limit, which we see from right hand side, is also 2. So both of these are approaching 2, so let's go for 2. All right, next, let me zoom it as much as I can. I hope it's clearly visible. If any of the question or anything is not clearly visible, do let me know in the comment section. And then I have limit f is defined for the real numbers. Okay, this one graph is broken here at x equal to minus 5. So this so for the limit x goes to minus 5, we don't even have to find the limits. It's broken here, the limit doesn't exist. So when the graph is broken like this, LHL is going somewhere else, LHL is 6 and RHL is going somewhere else, minus 4. We can just simply go for limit does not exist. Then again we have limit from the tables, x approaches minus 8, so minus 8 is here. Now as you can see, from RHL it is approaching minus 0.01. It's approaching, it's like, so these are y values, right? So y value is going like this, minus 0.01. It is approaching 0. And from the left side if we see the y is again going towards 0, so both are going towards 0, so let us go for 0. Both LHL and RHL are going towards 0. So this was our first lesson of limits intro. So they included both two questions were on limits from table and two questions were on limits from graphs. So in this series we're gonna cover only the questions, only the quizzes and the exercises part, right? And videos on topics and concepts will be recorded separately, and we will be putting those also. If you need help in any specific topic, if you need help in video on any specific topic, do let us know in comment section. All right, the function h is defined for real numbers, estimating limits from graphs. Okay, next one, limit x goes to -2. So let's go to x goes to -2. Here is x goes to -2. As you can see, it's a continuous graph, there's no break in it, and from left hand side it is approaching near -4, and from right hand side also it is approaching. We have to see the y value, remember that, the function value. This is the x value, right? So for limit x goes to -4, both LHS and RHS are going, both LHL and RHL are going towards -4. So now let's look at the options. So they have not given us -4, so we have to take the values as close as possible. As you can see, it's as you can see here, it's close to -4, so a good reasonable estimate is -3.8. Next, okay, there is the graph at x is equal to 4, the graph is broken. We don't have to find the LHL or RHL, the limit doesn't exist simply. Okay, again at x equal to 3, the graph is broken. So do let me know in the comment section what is LHL and RHL at x is equal to 3. I will really appreciate that. It will be a two-way communication. I will really appreciate that if you put it in the comment section like this: at x is equal to 3, LHL is this and RHL is this, and I will definitely comment on it whether it is right or wrong. So since the graph is broken, we don't have to find anything. It's just limit does not exist. Again, next, what is the reasonable estimate for limit x goes to 7? Now look at this. At 7, the graph is not continuous. But this is function's value. So function's value at 7 is somewhere between -3 and -4, right? But remember this line, very important. Value of function has got no role in finding the limit. So limit exists when LHL is equal to RHL, that's it. Here LHL, look at the way I'm finding the LHL. So for x approaching -7, I'll go close to 7 on the left side, and it is going somewhere between -6 and -7. So let's say -6.5, because I can see that number there also. From right hand side also, my RHL is also going towards -6.5. Function values is somewhere between -10 and -4. Again, it has got no role in finding the limit. The value of the function has got role in determining whether it is continuous or not. And as you can see, this is not continuous function. But for the concerned question, for the limit, it is just -6.5. Let's see if there is any other option in the -6. Okay, there is no other option which is in between -6 and -7. So -6.5 is the right answer. So that was finding limit from graphs. Next is, let's see, one-sided limits from graphs. So in this, we will be asked to find like only LHL and only RHL from the graphs. So the video has been for 9 minutes. We can do one more exercise. Function h is graphed below. Okay, so here you can see limit, it says limit x goes to -1 negative. Do you see this negative sign? This means that it is LHL. They are asking for LHL. This is left-handed limit for -1. Now look at the way how I will find LHL from the graph. So I'll go to -1. I will go close to -1, but from left hand side. And from left hand side, I can see that the graph is going down, down, down. So it's going -infinity. It's called unbounded. Sorry, we got some disturbance there. Moving on to next question. All right. So the graph h is graphed. Function h is graphed below. Again, it's a broken graph here at x is equal to 6. But in this case, we are looking for, see, do you see this positive sign? It means we are looking for RHL, right-handed limit. So we'll go to 6 because it says x goes to 6. We go to its right hand side, and then on its right hand side I'll go on to the graph, and I will see that where is that graph approaching. So as you can see, that graph is approaching -5, right? The graph is, put an arrow like this, the graph is approaching -5, and it also became this filled circle. This means value of the function. Let me erase it. Okay, this filled circle, this means value of the function. So value of this function at x is equal to 6 is also -5, and this open circle means when x is 6, this value is not there, this value is there. I hope you know the difference between filled circle and the open circle. So x goes to 6 positive, so 6 positive, it is -5. So let's go for -5. All right, next is we have HS graph below one-sided limits. What appears to be the value of x goes to 4 negative? Again 4 negative. I'll speed up the process now. That means I have to find LHL. So let's go to the graph. This value is approaching 3, so that means it is 3, right? Here they are looking for -5. So always remember, it's very important. Sometimes what happens is they break the graph at one point. Let's say they have broken the graph at -5, and they will ask you the limit. Let's say the limit sum at other point. Let's say limit x goes to 0 f of x. So when students see the question, their eyes directly go to the part where the graph is broken. But before that, make sure you see that what are they asking for. So if they are asking for, let's say, limit x goes to 0, then in this case it will be -2. So you have to look for what are they asking for, right? So now they are asking for limit x goes to -5 positive. Positive means RHL. Yes. So for -5 RHL, I'll go to -5, and I'll go to its right hand side, but I'll stay close to -5. You have to stay as close as possible. Now if you ask me how much closer, well, that's like not defined. It's like if I say, okay, 5, if I am close to -5, let's say if I am at -4.9, then you will say that, okay, -4.99 could also be there. Then I will say that -4.9999 would can be more closer. So it's just, you know, as close as possible. In exact terms, that number is not defined. So if I go to close and close and close to -5, I can see that my function is approaching 3. So the RHL is also 3. So that completes our finding one-sided limits from graphs. Is it recording? Yes. Now next is connecting limits and graphical behavior. Let's keep that for the second lesson. That's only